In this ExaCC quick demo, we are going to look at scaling OCPUs between different virtual clusters. In this Linux desktop, we have two sets of X windows running. The top set of windows represents cluster 1. The bottom 3 windows represent Exadata Cloud Customer Virtual Cluster 2. You can see in the middle terminal, we have a 4-node cluster with 8 threads on each node of the cluster. This represents 4 OCPUs. In the window directly below it, we see cluster number 2, which has 56 threads, or 28 OCPUs. In the right X windows, on the top, we are looking at Swing Bench running in character mode, generating a load against our Swing Bench schema on cluster 1. You can see that we're generating tens of thousands of transactions per minute. In the bottom window right below that, we have the same workload generation running against cluster 2 and the larger number of OCPUs and threads. And then to the very left, if you look at the top window on the left, we see that we have a VM stat running, which shows the run queue. The run queue is the CPU run queue, and you can see that it's quite large in the cluster 1, the cluster with the 4 OCPUs or 8 threads. You can see it's 20, 30, in the 50s. In the window below that, we have the run queue. Looking at the run queue for the cluster 2, we see that it's very low, 4, 6, 8 OCPUs. So this is our load that we're running. We'll then jump to the OCI Cloud Customer interface, and we'll see that in cluster 2, we have 112 OCPUs. That's 112 divided by 4, which is the 28 OCPUs per node in this cluster. You can see we'll hit the scale up button if we want to scale up the number of clusters. But before we do that, let's look at the other cluster, which is in a different compartment. And we see here in this virtual cluster, we have 16 OCPUs, or 4 OCPUs per virtual machine in the cluster. We'd like to go scale this up, but when we go to scale this up to give it more capacity, we see that it says there are only 4 available CPUs in the current allocation, and we've already allocated 4. So we don't have any CPUs, OCPUs, to allocate this to scale up. In order to do that, we need to shrink the number of CPUs in the other cluster. So if we bounce back to the other cluster and we go look at the scale up and scale down, we see here that this has 28 OCPUs. There's currently 28 allocated, which means we don't have any extra to allocate here either. It's the same Exadata infrastructure. So we'll actually shrink this down. To shrink this down, it's very easy. You just go ahead and highlight that, change it to 8, and hit Save Changes. So that'll be 8 OCPUs. You see the cluster is now updating. If we come back to the X windows, and let's watch this cluster shrink as we do this online without interruption. Remember, we did 8 OCPUs, which will bring this down to 16 threads. So here we go. We start seeing the node shrink. First node 1 is now shrinking. It's now at 16 threads. Shortly, we'll see node 2 shrink down to 16 threads, and so on. You notice that there's no interruption to our Swing Bench generator here on the right-hand side. We're still generating our transactions. We're still able to continue without interruption. What you will notice, though, on the left-hand side, in our far left X window in the bottom, our run queue is going to start to increase. This is because we've shrunk the number of threads or available CPU processes that we can execute at a single point in time. So you see where our run queue used to be 4 or 5, and so it's now getting up into the 10s and 20s at this point. So we've increased our run queue. We'll now go back to the cluster interface, the cloud at customer interface, and we'll scale up the other cluster. We should see in our other cluster now that we have available CPUs. We drill down in the cluster, go to scale up and scale down. Where we used to have 4 OCPUs available, we now have 24 available. So at this point, we can increase the number of OCPUs in this cluster, increase that to 8, hit Save Changes. Now, when we go back to our environment and look at the workloads that are running, we should see the threads increase to 16. Once again, that's 8 OCPUs per node. We'll look at the cluster 1 here. We see that there's still 8 OCP or 8 threads. We'll wait to see that increase to 16. We can once again see on the right-hand side that we don't have any impact to our swing bench load generator. We'll be able to see, hopefully on the left-hand side here in a minute, that the run queue should start shrinking dramatically as we increase the threads. And here you see the OCPUs are being increased from 4 to 8. Once again, that's 16 threads. We see this in real time. It happens on each node in the cluster, one at a time. Here goes node 3 in the cluster. And we should see node 4 increasing here. And what's even more interesting is, once again, you see the run queue for the CPU, which used to be 30, 40, 50, is now down to 8, 9, 10, very similar to the other node. Both clusters now have 16 OCPUs allocated to each one of them. If we jump back into the interface and see that the cluster is now available, once again, we increase to 8 OCPUs per environment. That's 32 total. And you can see here, we did this in roughly about 2 minutes. Okay, we executed this at 15:56 and it finished in 15:59. So just a little over 2 minutes to increase the number of OCPUs in the cluster. And you can see that there's still 24 OCPUs total available in the cluster for use. We're utilizing 8 of those. So at this point, once again, we took a look at how we allocate CPU resources between clusters using the Oracle Cloud Customer interface. This concludes another quick demo.